Hi, I'm Andre. I'm a software engineer, and today I will show you, we'll go over a simple implementation of a bus in order to use it in your application. You have a small application, you can use you can use that pattern. So you want to, like I said, implement a bus. What is your goal? You want to have a decoupled system using messaging approach, like an observer pattern or a publish subscribe system. If you are in C Sharp, you have events and handler. In Ruby, you have some other stuff. But usually, you can do your simple bus in order to make something cool. And yeah, like I said, you want something easy to use on your side for a small project. Okay, you want to have control on it. You want to understand how Bus works and how you can play with it and how you can register some event and command and some handler in order uh, to make it work. Uh, we will go over an example which will allow you to decouple your system. You will see it's at some point some easy, and you will be able to practice and have it on your own and be able to do some great stuff. From our documentation, okay, you've probably heard about messaging from Gregor Hope. Oops, I think I have a mistake here. I know. Okay, from Gregor Hope or SecureRS by Greg Young. Then you have a book which is called Enterprise Integration Pattern. There's a lot of stuff there like message broker, envelope. We will see over. You have Greg Young also that have cool ideas about secure arrays. Then you'll be able to, uh, if you mix those ID with patterns and your system, you will be able to get at some point that you can have many systems with context and DDD and all of those stuff. Uh, and you want to work with messaging system, like I just said earlier, there's a simple screenshot from Gregor Hope website. Then you have an application, you have another application, and then you have a pipeline like a wire. Then you can do some stuff on it. Okay, there. This is another approach for system messaging. Then you can have an envelope. You have many places where you can put uh, or add some tracing or something. I won't go deeper in this. I will just let you go on the website of Gregor Hopes if you just want to see the patterns. Then the solution today will be to just show you a simple system bus that would let you move on messaging easily. Hi, let's continue with the implementation, the code of my simple bus. You've seen in part one all the just documentation. Now we'll go over how we can do it. Here will be an example in Ruby, but you can do the same thing in another language. Okay, so let's start with we have like something that could be an event. Okay, an event could be like just a struct of data or something like a record and edit and a table, but don't put any behavior. Keep it simple. Okay. Then what you can have is a class user created event. Okay, because I want to create a user, and uh, you probably have a payload. Okay, which is cool there. It's by in another project we found out that having a payload like a JSON, it's much more easier. Then you probably have an ID for your event, and you just have a payload for that. But for this, okay, this is just an event. You will see it on Kafka and anything. You have to determine what is your event, your structure of event. But you need some kind of handler. Okay, if I just paste here my notes, okay, we need an handler. There's many ways to bind an event with an handle, like I handle event if I am in C sharp using reflection, using an attribute if I am on C sharp also, having explicit property. Uh, like we will do probably here. You can also have an array which you set my event and you add those handler. Like I said, this example is a simple one. Okay, if you use like Kafka, probably you will have a more powerful framework to do it. But here is something that you can do on your own small project. It will be always the same, and you'll be able to try to experiment the bus pattern. So here I have an example. I need an handler for user created event. Okay, let's go. I just call it an handler for user created event. And like I said here, I use like a method called handling of class name, which is the event on which I'm binding it. And I handle something, and here I will be able to put some business values or some. I just said business value, but remember, it's not a good practice to put code in on-click event. Like if you have to put something, it's like the hexagonal pattern. You will have a trigger. A trigger should call a class of your domain. You should avoid putting business rule here because it will hard to move on or to extract business rule from there. This is just a trigger. It should trigger something else, which will be the aggregate by example. And then, like I said, we need a way to register or to bind the handler with the event. Okay, at some point, I can use a repository, handler repository. Okay, let's say we have that handler repository. Just add some lines here. Okay, we have a repo to register the handler, which is basically a class. Okay, handler repository, which inside I will use just an array. Like I said, it's a simple way to do it. Okay, then I want to be able to register my event, so I can just define a method that will as register event name and an instance. Okay, or something more with Ruby, we can do something much more a little bit advanced. You can just put the instance, and from that instance we will use the instance of with the instance, then we will register something and we will put the instance and the handlers. Okay, here this is a way we can do, or we can defer it when on call. We'll see I modified the bus to use just the instant and to call the handling of each time. There is different way of implementation, but the basic thing is you have to have a way to know on this event you have to execute those handlers. Okay, this is free to you to decide how you will bind those stuff, but like in pattern, keep them simple. Also, then I have a way to register my handler, and I have a way to get those handlers for a particular event. Then it's here where I just look through my array, and then I select only the handler I want for that event. Okay? Like I said, it's a simple one. Now we can go over the bus. Get the bus. This one is a synchronous bus. If you want to do some pattern with asynchronous in C#, you can use async method or something like this. You can dispatch the call on another thread, or you can go over and try to experiment. But like I said, the pattern is still the same. You have a way to bind an event with handler, and then how you do it, you can experiment some stuff, and then you will be able to learn and experiment and have some learning about failure you do. Okay, then same thing. I have my simple bus here at class. What I have in there, I will receive a handler repo. The repository that I has made before, I should inject into my simple bus. Okay, you will see why there's no new here, because it's dynamic. From another project or from discussion we had over time, okay, you send a command and you publish an event. This is why I have two call here. Basically, it's the same thing. I know it's, but at some point in a project, we divide the bus in two. We add the command bus and we add the event bus. Because on a command bus, at some point, you don't really need a transaction. You send a command and you hope that that command will reach some aggregate. But when you receive an event, at some point, when you publish an event, at some point, it could be part of a transaction. Then if the aggregate fail or something on the event failed, then you can revert all the stuff. But this, I won't go too deeper in that part. I refer you to, by example, Sam Newman with Monolith to Microservice. He explained a bit, and also you can see on Kafka about delivered ones and all those 4 patterns about how a message should be handled. Okay, but I don't go too deeper in that, but just say that you send a command and you publish an event. Okay. But now, okay, I've made some implementation. How this works now. Let's say I have, I would just do like a basic code here. Then I have to define my handler repository, okay, because this will be a dynamic instance. Then I have to register my handler. I use, like I just showed you handling of, but I just have to put instance of it. Then I will have to create just an instance of it and then register it. This is why container object or dependency version of Solid come into play. You will be like doing aspect-oriented object, which at some point you create dynamic information, which you will register. It's not doing new all the time. It's just you should have at an entry point in your application. When you start, you register all your services, and then this will be dynamic. Okay. Then after that, you should be able to register to create the bus. Okay. The way it's like a proxy at some time. Okay. We have a way to register. Then I'm able to just define the bus. Okay. I can be also defining the bus before, but I'm still be able to register my event. Okay. With the container, an version of control container works. It will on call, it will try to build the services you need and all of these dependencies, and then it will give you the bus. Then you just have to put somewhere in the star what are the event handler you need. And you can, with this, you can also add an event and remove an event. If you are in C#, by example, you have a plus equal, an event handler, and minus equal, and another event handler. Then it's the same, basically the same thing. Okay, then I've defined an handler repository. What should I do now? I'm just able to create an event. By example, I want to publish a user-created event. I just put an event with a payload, some value, then I publish the event. Okay, let's see now. That's cool. We just created one event and one event handler. Can I create another handler for that event? No problem. I just come here. I have a user created event handler in one context. Then here it could be it's a user. It's a user meta. Let's say we have a grocery, not a grocery, but we have a context. We'll just say we have a module A, okay, where we have this event, and we can also use the same event for another context in another module. Then we can have context B, user created event handler on the same event. So if you have followed me, what I should do here, I just come and I create the context B user event handler. Because it's based on the class name, at some point, you can also have context B module, context B, user event handler. It doesn't matter if this is the same name as the other one, because you have created module in which you can repeat names, and you, by the module name, it won't be a collision of name. Okay? And when you will publish the name, like I told you, it will look for all the events, all the handlers that should correspond to that event, and then execute one by one. You'll see, oh, one by one, what I do for the order. This is not part of this, this presentation, but if you have something that you have to keep an order, sometimes you have to think, okay, if I have an order, probably I have to send something before. Look at my post for Apple and Arrange for messaging. You will see that I have to prepare the environment before I begin acting on it. Okay? So, okay, the same thing. Let's say I have a comment. Okay, what should I do now if I have a comment? It's the same pattern. A comment will act like an event. At some point, aggregate. The command will trigger an aggregate and send an event. Okay. Here I have made some shortcut to go to for the example. But if you have a command, what you should have at some point, you will have correlation ID, because you should, when you send a command, it will send a lot of event, and you want to be able to trace back event and command that relate to which particular process. Okay, this is just a point about correlation ID. You can refer to the book messaging to know more about that. Okay, then the same pattern applies here. I need, whoops. I need, I have to cut it there because it's how it should be done. Okay, you have an handler, and then you have handling of. Okay, let's say I have the handle command. Okay, do cool stuff. What I should do now with my command, add the same thing as we just did earlier. I just register a command that new, and then when I will want to send the command, I would just have to create a command. Where's my command? Create a user command here, and then get that new. I just take my example this, and okay, and then boss, it's a command. It's a command, then I should call send. Okay. We have an example of, this is the consequence of the command. At some point, we know more this one, but what we do with this one, where we put that code, okay? At some point, it's the cool stuff here. The cool stuff here will be your aggregate. I send a command. The command will load an aggregate, and it will do an action on it. Okay, a command, it's an action. And then the aggregate will do some business rule and will publish events. So what I have to put back here I just made an act just to show you, but when I send a command, it will track back, it will get back from the command the correlation ID, and it will publish an event, okay? And here we just have to send a command, and when the command is executed, it will get the aggregate. The aggregate will create events. The events will now be published. And then because we re-enter the loop in the bus will detect, oh, I have now to handle events. Then which handlers is tied to that event, then the event will be executed. And basically, this is a way you can just implement easily a bus. let's say I have made it in, I don't know, it's not so much time, no much time, but you have a real example how easy it's, you can do it, and you can start playing with that tomorrow if you want. Okay? You can make the same thing in C++, in C Sharp, in Java, in Ruby. Basically, it's the same thing. Let's have fun.